In this video, we are going to see about linear regression. Regression, it is a set of machine learning methods which is used to estimate or predict and continuous outcome variable based on the uh, available predictor variables. The predictor variables may be one or multiple. On general regression, it is a method which is used to forecast and find out a cause and effect relationship between the variables. It provides a linear relationship between the expected outcome and the predicted variables. For example, when we are trying to sell a house, how much the price of the house, or what is the estimated or predicted distance from the home to the shopping mall or something else. So these are all continuous variables which we are going to predict. For this type, we use regressions. One such type it is linear regression. Linear regression, it comes under supervised algorithm which have some set of training values. These training values will have one or more input values and a single output value. This algorithm will try to fit a best fit line among the training samples. From the best fit line, it learned to use to predict the output of the input value we are giving. In common, we can say linear regression computes the linear relationship between the dependent variable and an independent features by a linear equation based on the observed or given data. In classification, we categorize the classes within the given set of values. For example, whether it is a dog or a cat. In regression, we need to expect or forecast or predict a continuous variable from the input vectors. We have, as stated earlier, it gives a relationship between the dependent variable and the independent variable. We are taking the dependent variable as y and independent variable as x. If your output vector is dependent variable which has multiple dependent variables, then the regression is called as multiple regression. In a linear regression, suppose if we need to find an unknown parameter y with an parameters as it is a function of y with x and the parameter value w. So it can be expressed in the terms of y is equal to w transpose some function which is a nonlinear function of x. X is an input. Y is the function of x. Y, it is an independent variable. Sorry, y, it is a dependent variable dependent on the input x. Here, x is an independent variable which are all our inputs. Y, it is an dependent variable of outputs. So these are the data points that maps the independent variable and the dependent variable. Our main aim in linear regression is to find the best fit line along the data points to separate the data points. So we have to find a best fit line using a simple mathematical model. So here comes the best fit line along the data points. These are the data points, data points, data points. The difference between the data points and the best fit line is called as the residue. We can say the difference between the predicted point and the actual observation is the residue. Linear regression based on the mathematical expression y is equal to b naught plus b1 into x plus e, where this b naught is the y-intercept, b1 it is the slope, and x is an independent variable. We have y is a dependent variable with an error function. This error function should be minimized as such as possible to get the highest performance of our model. If you see this equation, it resembles like your your straight line equation, that is y is equal to mx plus c. This is the straight line equation where m is the slope and x is an input and y is an output. So same here, b1 is a slope and error value. This is an y-intercept. This equation fits for this model. And regarding the cost function, linear regressions and all the regression techniques will be determined on the least square error calculations. Our aim is to minimize the error as low as possible to increase the performance of the model. A linear equations, sometimes it may be b naught plus b1 into x, sometimes it is a naught plus a1 into x. So our motive of the linear algorithm is to find the best values for a1 and the intercepts and the slope. So this is our best fit line. These are the data points along this hyperplane. So we need to find the equation y is equal to a naught plus a1 into x. As I said, the linear regressions rely on the minimizing of error between the predicted value and the actual value. So upon the several trials, the predicted value is difference between the output value and it is calculated by the least square mean. So this equation says the name of least square mean. So difference of predicted value minus actual value, then squared, and the mean of the different iterations which have gone. So this says how the cost function can be used to find the best fit line for the data points. Let us take a simple example. Here we have a linear equation, regression equation for the following data sets. We need to find the best fit value of A and B for the equation. So sometimes it may be written as a naught plus a1 into x, sometimes b naught plus b1 into x, sometimes it is a plus b. The variables may differ, but the concept is that it is same like the equation y is equal to mx plus c because it is a linear one. So x is equal to 2, 4, 6 and 8. Corresponding y values are of x is equal to 2 is 3, for x is equal to 4, 7, for x is equal to 6, the y value it is 5, and for 8 it is 10. To find the a and b values, we need to find a and b values by the formula xy mean minus x mean into y mean divided by x square's mean minus x mean the whole square. So xy the mean. Okay, so for finding out these values, we need to calculate x into y the mean, y the mean. So I have drafted an table x. So given it is 2468, x 2468, y 375 10, 375 and 10. So we need to find x into y, x into y. So 6x into 3 into 2 6, 4 into 7 28, like that, x into y, and x square. So 2 square 4, 4 square 16, 16 square 6 square 36, 8 square 64. So next we want the mean of xy mean. So add it, 6 plus 28 plus 30 plus 80, the whole thing divided by its mean, so it is 4. So the mean of x into y mean, it is 36. Like that, x mean 2 plus 4 plus 6 plus 8 divided by 4 5, and same like y mean and x square mean. Substitute all those here to find b value. So on substituting the values, the b value obtained was 0.95. A is equal to y mean minus b into x mean. So on substituting a is equal a, we get 1.5. So the best fit line for the given data values is y is equal to 0.5, oh sorry, 1.5 plus 0.95 into x. So this gives the best fit line. This is how, on whatever the database we dataset given, we need to find an linear regression model with a simple mathematical formula. Regularization. We extend the trainings of the linear model with regularization methods in order to improve the performance. Actually, we evaluate the linear regression model by using some parameters like linear square values and root mean square values. So with these values, we need to extend our training process by using the regularization methods. There are two regularization methods commonly used for linear regressions. One it is lasso regression, another one it is rigid regression. Lasso regression, where your lean square model is summed up with an penalty of term of absolute sum of coefficients, regression coefficients. Rigid regression, it will have added with the penalty term of squared absolute sum of coefficients. Rigid lasso regression is also called as L1 regression. Rigid regression is called as L2 regression. This is the equation. We actually, it is the sum of squared residuals. This is actually your least square error plus your slope square. It is rigid regression. Only with the slope, it is lasso regression. These lasso and rigid regression are used to increase the performance, optimize the model of linear regression model. So these are some of the examples of linear regression cases where it is used to predict the sales forecasting Risk analysis, like how much time this patient will be available with these will be will have his lifetime with this complement characters, and housing applications, like predicting the sales value of this house for 2 BHK or 3 BHK, or within the area where the house it was. So like this, and finance application for predict the stock prices, like this. So these are some of the you could say that all these applications will have an continuous value. And the implementation of linear regression, it is by loading data and exploring the data, what is in the data, and slicing the data, that is dividing the data using the parameters or factors which are characterized together, and then training the data and split the data for testing and training, and generate a model and evaluate the model by using this least square mean error and root mean square mean error, or squared mean error. And after evaluating the accuracy of the model, we need to improve the model's performance by using the regularization techniques like lasso and ridge regression. Once it is you understand the topic, you go and take an assessment quiz on CAFT.